All right, so this is our last case, case 3, where the same firm, all right, is facing again the same labor supply and output demand curves, exactly the same production function. The only difference is now the firm is perfectly competitive firm in the output market, all right? However, it's the monopsony in the labor market, all right? So in the labor market, it's the only firm that hires laborers, only buyer. But in the output market, there are many sellers selling exactly the same product, and our firm is just one of them. So in the output market, the firm is going to take the output price fixed, and in the labor market, it's going to face upward sloping supply curve. All right, so that means the revenue of the firm, the monopsonist, is going to be different. What is it? Again, as always, revenue is price of the output times the number of output, and then the cost is the price of the input times the number of input. The number of output is always denoted by our notation y. The number of input is denoted by x. The price of the output, here, the output market, the firm is competitive, so therefore it's going to take the price as given. So it's some p, which is given. I can't change it. So therefore it's not p of y. It's just p, determined by the market demand and supply curve. Well, what about the price of input? It's not the only buyer. It is the only buyer in the labor market, in the input market. So it's going to face an upward sloping demand curve, which is going to be a function of x. All right? So therefore, the profit function is the price times output minus price of input times the number of input. The optimization problem is to maximize the profit by choosing not only x but also y, some non-negative numbers, but obviously don't forget we are always subject to the production function where if you hire x many inputs, you can produce y many outputs, no more, no less. Okay, so again, I can rewrite this as maximize the profit by choosing x only, because I'm going to substitute whenever I see y, I'm going to write f of x, r plus. So the pi is p times f of x minus wx times x. So please go back to the previous video and verify how different it is. All right, so here I have a function, not a constant number, and here I have a constant, not a function. So when I take a derivative, the derivative of constant is just 0, so therefore I'm going to take the derivative of the fx term. And here I'm going to take the derivative of this term multiplied by the second term, and then I'm going to take the derivative of the second term and multiply it with the first term. So the first order condition is the derivative of the first term is simple, p times del f del x, f of x del x, minus the derivative of this term, which is the derivative of w of x del x times the second term, minus, it's going to be this plus the derivative with respect to x, but because of this minus distributes, it's going to be minus. The derivative of x is just 1, so it's w of x equals 0. So send all the negative terms to the other side. This is going to be our marginal cost plus w del w del x of x, all right, equals p times f prime of x. All right. So this is again p times marginal productivity, which if you remember from case 1, and this is this is kind of marginal revenue in this new framework in the factors market. So in the factors market, the marginal revenue is different than the standard marginal revenue. In the standard marginal revenue of a perfectly competitive market, marginal revenue was equal to P. But when we consider the input and output market, then the derivative of F, the marginal productivity, kicks in. So the marginal revenue becomes marginal revenue of the competitive labor market or input market becomes P times marginal productivity. Okay, that's the difference. So this is marginal cost. And what do I know? I know that The Wx is a function, so it's a positive function. The dw dx, so this is the derivative, the slope. So the supply curve is an increasing function, so therefore this number is always positive. So this curve, well, this is a function, is higher than the supply curve, all right? So I have to draw a graph higher than the supply curve. Well, why does that matter? So again, if I knew the demand curve, the supply curve, the production function in a question, I can numerically solve the optimal number of labor the firm hires by just solving this equality, all right? But because I don't know these functional forms, this is not a numerical example, which is the next video. Well, nevertheless, I can compare the optimal outcome and prices in the labor market with the case 1 optimal levels. Here's how I do that. So once again, I draw the labor market. X is on the horizontal axis. This is wage and everything related to money. So remember, this is assuming that the inverse demand curve P is linear, P times f prime of x, assuming that the production function is, again, a linear, for example. So we would have a linear P times marginal productivity curve, all right? So what else? We have the marginal cost curve, which is, the supply curve, all right? We don't have marginal revenue product, remember, because the case 2 had that. In case 3, we have a different scenario. Our marginal revenue is this guy, is this black downward sloping line. The marginal cost curve of, this function, Wx, is the marginal product, marginal cost in case 1. However, we are in case 3, our marginal cost is higher than this supply curve. Higher means it's steeper, something like this. This is Wx plus dw dx, okay? So, therefore, the optimal number of laborers the competitive firms would hire is xc, and the wage the competitive firms would pay, this is wc. However, the marginal revenue equals marginal cost, right? That's the point where the competitive firms will choose X. In the case 3, the monopsonist is going to choose marginal revenue equals marginal cost. So this point of intersection. And so this is going to be the X monopsony. Monopsony? PT, I don't know, monopsony. I don't know why PT. MT, I'm sorry. So the optimal labor in the monopsonist or monopsony case, it's lower. Okay? What about the wage? Is it this one? No. In order to find the wage, we have to go to the supply curve. So this is the supply curve, right? This is not a supply curve. This is a marginal cost curve. This is the supply curve. So therefore, this is the MT, the monopsonist's wage. Okay? All right. So that's it. So in conclusion, the monopsonist is going to hire less labor and going to pay lower wages. All right? So that's the conclusion. So the question is, once again, why the wages are lower and why the monopsonist hires less labor. It's not because the monopsonist is going to produce less output, because we don't know that yet, all right? Probably it will, but the idea is that the marginal cost for the monopsonist is higher than the marginal cost of the perfectly competitive firm. And the reason for this is that for a perfectly competitive firm, the marginal cost, the cost per additional labor, additional input, is just a fixed number, the wage of that labor, and it's fixed. I can't change it. However, for monopsonist, if I would like to increase the number of labors, the number of inputs 1 unit, well, I have to increase the wage, right? Because the supply curve is an increasing function. If you want to hire more labor, you have to increase the wage. So, but the thing is, the wage of that labor increases, but because the monopsonist is paying uniform pricing, meaning uniform wage, so all the laborers will get exactly the same wage, well then the wages of all the employers, all the workers will increase. So that increases the marginal cost of the monopsonist above the marginal, the wage or the cost of the marginal cost of the competitive firm. So again, the uniform pricing, again, in sort of the key reason for this. Obviously, in reality, the wages are never the same, right? Different departments hire different workers with different skills, and they pay differently. So even in the same department, people are paid differently. So in reality, things are more complicated. But assuming in this very simple model, the wages of all the workers are the same, that's the reason why the marginal cost of the monopsonist is higher than the competitive firm. Well, because the marginal cost is higher, the firm would like to choose less of a product. So although this firm, the monopsonist, is perfectly competitive in the output market, so it's perfectly competitive, it's going to take the output price as given, so it would like to produce as many output as the other firms, but because it's the only buyer in the labor market, that will implicitly influence its behavior in the output market. Sorry? So it's not going to behave as if it is a perfectly competitive market in the output market. A perfectly competitive firm in the output market. Okay, so one last thing that I would like to add before finishing this video, and in the next video I'm going to solve a numerical example, the relationship between the monopsonist behavior and the minimum wage. So normally, I mean, when the market is perfectly competitive, the labor market, so this is X, the number of laborers, and this is the wage. So this is the demand curve for the labor, this is the supply curve for the labor. So this is the competitive equilibrium number of laborers hired, and this is the competitive equilibrium wage. So in a perfectly competitive market, the minimum wage, effective minimum wage, will increase unemployment. How so? Well, if you set the minimum wage something like this and say, oh, you cannot pay workers lower than this wage, this is not effective because the firms will say, oh, we already pay WC anyway, so it's not effective, it's not going to work. So an effective minimum wage is something like this, a minimum wage set above the equilibrium price. Well, if so, what will happen is that the supply will increase to this point, X supply, and the quantity demand will be this, XD, and so the difference between is positive, so we call it unemployment. So more people are willing to work at that price, but less firms are willing to hire because it's too costly for them. So the minimum wage, the lesson, is that the minimum wage increases effective minimum wage, increases unemployment in a perfectly competitive market, at least theoretically. But what about the monopsonist? I'm sorry. So for the monopsonist, we have the demand curve for the monopsonist. We have the supply curve for the market, and we have the marginal cost curve, if you remember. So this is the competitive equilibrium number of workers, and this is the competitive equilibrium wage. However, less is the monopsonist, a worker is hired, and they receive monopsonists pay less. So what happens is that at this price level, at this wage level, we have demand this much, but the supply this much. So the monopsonist would like to demand, I mean, it demands, but the thing is, there is not enough supply, all right? So it's not unemployment, but the employment is less than the optimal level being the competitive equilibrium level. So if the government imposes minimum wage above the competitive equilibrium wage level, again, it's going to increase the supply over the demand, and so it's going to increase and cause unemployment. However, if the government imposes minimum wage in this region, for example, somewhere here, what happens is that the demand shrinks, but the supply increases, most importantly. So the the employment will increase. And so the market will be more efficient. The input market will be more efficient. So in the monopsonist, I mean the firm that is monopsony, minimum wage, effective minimum wage below the competitive equilibrium wage level increases employment and hence reduces inefficiency. Unlike the case in perfectly competitive markets, the minimum wage will never increase unemployment. I mean, it will increase unemployment. Minimum wage will always increase unemployment. And so it will always be inefficient. Okay? So some government policies increases inefficiency in some markets, and the same government policies could actually increase the efficiency and decrease the inefficiency in some other markets. So for that reason, it matters on which market you are operating and on which market you're implementing the strategy. All right, I hope that was clear. I'll see you in the next video with the numerical example.